See, in this question, a single line diagram of a lossless system is given. The system is operating in the steady state at the stable equilibrium point with the power output as a Pmax sine delta, where delta is a load angle and the mechanical power input is a 0.5 Pmax. If fault occur into the line number 2 such that the power output of generator is become less than 0.5 during the fault. That means that during the fault the power output is become less than 0.5. After fault is clear by opening the line number 2, the power output of the generator is become P max by root 2 sine delta. If the critical clearing angle is the pi by 2, the accelerating area on the power angle curve is, see, let me draw the power angle curve for the three condition. In the normal condition, the power angle curve is like this. It is a P max sine delta. It is given. The maximum value is a P max. So this is a P max. It's a P max sine delta. And the output is mechanical input is the 0.5 P max. 0.5 P max. That means this is my operating point. Whenever the fault occur, the generator output is become less than 0.5. So during fault, the maximum power is become less than this. So during the fault, this is my power angle curve. It is less than the 0.5. So this is the during fault. This is a during fault. Now, after the fault clearing, it is become P max by root 2 sine delta. So now it is become like this, P max by root 2. That means it is more than P max by 2. So this is the P max by root 2 sine delta. It is become P max by root 2 sine delta. Now see, this is my operating point. Whenever the fault occur, the operating point immediately shift to this point because this is the curve during the fault time. And then what will happen? It will move like this. At alpha equivalent to 90 degree, this is my critical clearing angle. So at critical clearing angle, it will again move to this point and then it will go like this. This is my critical clearing angle, always remember. So only this area is available for the deceleration. This is the accelerating area, this is the deaccelerating area. And this is my critical clearing angle, delta C. Now, if I see this angle is a delta 2, this is the maximum angle is available. This delta 2, if I take this angle as a delta 1, if I am taking this angle as a delta 1, you can say the delta 2 is nothing but the 180 or the pi minus delta 1. It is nothing but the pi minus delta 1. In the critical clearing angle, the total available deaccelerating area should be equivalent to the accelerating area. So for critical clearing angle, total available deaccelerating area is equivalent to the accelerating area. Now we have to find out the accelerating area. So accelerating area we cannot find out because this angle we do not know. So, but we know that the deaccelerating area. So we can find out the accelerating area that is equivalent to the deaccelerating area. So the delta C is the pi by 2. It's a pi by 2 only. And what is the delta 1? See, at the delta 1, this is the P max by root 2 sine delta. Always remember, this is P max by root 2 sine delta. This yellow one. And this green one is a P max sine delta. The equation of this is not, we do not know. So I cannot find out the accelerating area directly. So I will find out the accelerating area by equalizing this area is equivalent to the deaccelerating area. So at eta to alpha 1, this is the P max by root 2 sine delta. At delta C equivalent to pi by 2, the P max by root 2 sine delta, sorry, at delta 1, it is become equivalent to this point, and this is the 0.5 P max, 0.5 P max. So the sine delta is become 1 by root 2, because it is become 1 by 2 root 2. So the delta 1 is nothing but the 45 degree. So the value of delta 2 is nothing but the pi minus delta 1, pi minus 45 or 180 degree minus 45, that is the 135 degree. So 135. So accelerating area is equivalent to the available deaccelerating area. Now, so the total deaccelerating area, so let's find out the deaccelerating area. See, this is the deaccelerating area. This is P max by root 2 sine delta, and this is the 0.5 P max. So the difference of P max by root 2 sine delta minus 0.5 P max d delta, and take the integration between delta C to delta 2. Delta C is the pi by 2 and the delta 2 is the 135 degree. Pi by 2 means there is a 90 degree. So you will get the P max by root 2 cos delta. The integration of sin delta is a cos delta, and it's a 90 to 135, 90 degree to 135 degree. And this is 0.5 P max minus 0.5 P max, and this is the delta. Again 90 degree to 135 degree. I will take it in the term of radian only. In term of P max, no doubt, P max we can take as a common term. So cos 90 minus cos 135 divided by root 2. Cos 90 is a 0 degree, and this is a minus 0.5. Angle 135 minus 90, convert this into a radian, so it is become pi upon 180 degree. If I calculate this, I will get the value of 0.107 P max. So 0.107 P max is a right option. Is the right option.